We only live in a moment in the universe, but we long to understand eternity. Hello everyone, I am Sam. Welcome to Reading and Sharing. Today I bring you a brief history of time. Hawking used it to answer countless ultimate questions about the universe, time and life, tiny specks on a tiny planet. And yet, we look up. We wonder, how can our minds confined to this small world even begin to grasp the vastness of the universe? The universe is bigger than we can imagine, older than time itself. It's full of mysteries, of stars that burn for billions of years and galaxies that spiral through the darkness. And somehow, we have the audacity to ask, how did it all begin? It's a question that has haunted humanity for millennia. Ancient civilizations told stories of gods and monsters, weaving myths to explain the cosmos. But it was science, through careful observation and rigorous testing, that began to unravel the universe's true story. Stephen Hawking, in his book A Briefer History of Time, takes us on a journey. He guides us through the complexities of the cosmos, making the strange familiar and the profound accessible. He reminds us that the universe is not unknowable, but a grand puzzle waiting to be solved. Imagine a time before time, a point so small, so dense that it contained the blueprint for everything we see around us. This, according to our best understanding, was the singularity, the seed from which the universe sprang. Then, the Big Bang. Not an explosion in space, but the expansion of space itself. A moment of unimaginable heat and density, followed by a rapid cooling and stretching. From that primordial soup, the first elements emerged: hydrogen, helium, the building blocks of stars. The universe, once a tiny point, began to grow, and it's still growing, expanding outward like a balloon being inflated. Galaxies rush away from each other, driven by this cosmic expansion, and as they move, they stretch the very fabric of space-time. This expansion gives us a direction to time, what we call the arrow of time. It's the reason why we can remember the past but not the future, why eggs break but don't spontaneously unscramble. Time in our universe has a direction, an arrow pointing from the Big Bang towards some unknown future. The universe is not a static, unchanging place. It's a dynamic, evolving system governed by forces we are only beginning to understand. Gravity, the weakest of the fundamental forces, sculpts galaxies and dictates the dance of celestial objects. And nowhere is gravity's pull more intense than around black holes. These cosmic monsters, formed from the death throes of massive stars, warp space-time so severely that nothing, not even light, can escape their grasp. Hawking, through his groundbreaking work, showed us that black holes are not eternal prisons. They actually evaporate, slowly radiating away their energy in a process now known as Hawking radiation. It's a testament to the interconnectedness of the universe, where even the most extreme objects are subject to the laws of physics. Einstein's theory of relativity revolutionized our understanding of gravity and time. It tells us that time is not absolute, but relative to the observer. Time slows down in strong gravitational fields, meaning that time passes slightly slower for someone living at sea level than for someone on a mountaintop. If relativity governs the large-scale structure of the universe, then quantum mechanics reigns supreme in the subatomic realm. It's a world of strange and counterintuitive phenomena, where particles can exist in multiple states at once, and uncertainty is a fundamental principle. One of the most perplexing aspects of quantum mechanics is the role of the observer. The act of observing a quantum system seems to influence its behavior, collapsing the wave function and forcing the particle to choose a definite state. This raises profound questions about the nature of reality itself. Does the universe exist independently of our observations? Or does our consciousness somehow play a role in shaping the reality we perceive? These are questions that have puzzled physicists and philosophers for decades, and there are no easy answers. Hawking, despite facing incredible challenges, never stopped asking these big questions. He sought to unify the seemingly disparate worlds of general relativity and quantum mechanics to find a single theory that could explain the universe at all scales. His book, A Briefer History of Time, is a testament to that quest. It's a book that invites us to marvel at the universe's grandeur while also grappling with its deepest mysteries. It reminds us that science is not about memorizing facts but about asking questions and seeking answers, even if those answers lead to more questions. Hawking's legacy is one of curiosity, perseverance, and a deep-seated belief in the power of human ingenuity. He showed us that even in the face of adversity, the human spirit can soar, reaching for the stars and daring to unlock the universe's secrets. The universe is vast, incomprehensibly so, and we in contrast are incredibly small. Our lifespans measured against the cosmic clock are but a blink of an eye. Yet we have this remarkable ability: we can understand. Our brains, these complex networks of neurons, have evolved to make sense of the world around us. We can look up at the night sky and comprehend that those twinkling points of light are not just pinpricks in a celestial tapestry, but vast, burning balls of gas, some larger than our entire solar system. We can trace the life cycle of stars, from their fiery births in nebulas to their eventual deaths, some collapsing in on themselves to form black holes. We can map the universe, charting the distribution of galaxies across billions of light years. The very fact that we can ask these questions, that we can even begin to comprehend the vastness and complexity of the universe, is awe-inspiring. Understanding the universe changes us. It humbles us, reminding us that we are but one species on one planet orbiting one star in a galaxy of billions. It shifts our perspective, making our everyday worries seem insignificant against the backdrop of cosmic time and space. But it also empowers us. It reminds us that we are a part of this grand cosmic story, connected to everything around us by the same laws of physics and the same fundamental building blocks. The atoms in our bodies were forged in the hearts of stars, scattered across the universe in supernova explosions. We are quite literally stardust. Knowing this, feeling this connection to the cosmos, can be a source of profound wonder and inspiration. It can fuel our curiosity, drive us to explore, and push us to become better stewards of our own planet. We may never have all the answers. The universe is full of mysteries, and for every question we answer, new ones emerge. But that's okay. The journey of discovery is just as important as the destination. The universe is not a finished product, but a work in progress. It's constantly evolving, expanding, revealing new secrets. And we, as curious beings, have a front row seat to the greatest show in the cosmos. So let us never lose our sense of wonder. Let us never stop asking questions, exploring, and pushing the boundaries of what we know. For in the words of Carl Sagan, somewhere, something incredible is waiting to be known. As we explore the universe outside, we also journey inward. The same curiosity that compels us to study distant galaxies also drives us to understand the complexities of our own minds. The universe is not just out there, it's also within us. In the intricate workings of our cells, in the electrical impulses that fire between our neurons, in the very essence of our being, we are, each and every one of us, a microcosm of the universe itself. And just as the universe is full of wonder and mystery, so too are we. We have the capacity for great love, for profound creativity, for unimaginable acts of kindness and compassion. We are, in a sense, the universe becoming aware of itself. Let us never forget the wonder of being alive, of being conscious, of being a part of this grand cosmic experiment. For in the end, understanding the universe is not just about knowing how it works, but about understanding who we are.